Have you ever felt true cold? Not the chill of winter, not the bite of wind, but the kind of cold that stops your breath before it leaves your lungs. The kind that turns metal brittle, that freezes oil in pipes, that makes your thoughts slow. In Oymyakon, Siberia, the coldest inhabited place on Earth, temperatures dip to minus 46 degrees Celsius. There, life is a struggle. Machines fail. Planes cannot take off. Even steel cracks under its own weight. Now imagine 5 times colder, minus 235 degrees Celsius, where nitrogen doesn't just freeze, it becomes rock, where methane is solid as granite, where the air is so thin it barely exists. This is not a dream. This is Triton, the coldest known object in our solar system. A frozen moon orbiting Neptune, smaller than Earth's moon, larger than Pluto, and yet it defies everything we thought we knew about icy worlds. It has geysers. It has volcanoes. It has an atmosphere that grew warmer over decades. It moves backward. It was not born here. It was captured. It may have an ocean beneath its ice. And if it does, it can hold life. Not complex, not intelligent, but alive. And it is dying, slowly, silently. Its orbit is decaying. In 3,600,000,000 years, Neptune will tear it apart, and Triton will become a ring, like Saturn's, but darker, colder, more beautiful. We saw it once, just once. In 1989, Voyager 2 flew past, took pictures, listened to its winds, then left. And since then, silence. No probe has returned. No telescope has seen enough. But what we saw changed everything. This is not a moon. It is a mystery, frozen, alive, doomed, and we are only beginning to understand it. Triton was discovered on October 10th, 1846, just 17 days after Neptune itself was found. For nearly 4 decades, it had no name. It was simply Neptune I. Then, in 1880, French astronomer Camille Flammarion suggested calling it Triton, after the son of Poseidon, the Greek god of the sea. A fitting name, because Triton does not belong here. It is a refugee, a wanderer from the Kuiper Belt, a vast region of icy objects beyond Neptune. It was captured by gravity, by chance, by cosmic violence. It did not form around Neptune. It came from somewhere else. It was once a dwarf planet, a twin to Pluto, orbiting the sun alone, until Neptune's gravity caught it. It was pulled in, slowed down, captured, and forced into a new orbit. The process was violent. It likely destroyed other moons. It caused tidal heating. It warmed the interior. It melted ice. It created the ocean beneath the surface. And now it is paying the price. Because retrograde orbits are unstable. They decay, slowly, relentlessly. Triton is falling toward Neptune by 1 centimeter every year. It will not crash. It will be torn apart by tidal forces. In 3,600,000,000 years, it will cross the Roche limit, the point where gravity pulls harder than the moon's own strength. And then it will break into pieces, into rings, a halo of ice around Neptune, a ghost of a world. The surface temperature of Triton is minus 235 degrees Celsius. That is not a typo. That is reality. At this temperature, water is harder than diamond. Nitrogen is solid as concrete. Methane is a brittle crust. Carbon monoxide freezes into snow. The air pressure is 100,000 times thinner than Earth's. It is not an atmosphere. It is a whisper, a trace, a ghost. And yet, it exists. And it changes. When Voyager 2 flew by in 1989, scientists expected a frozen wasteland. What they found stunned them. The atmosphere was thicker than predicted. The surface was warmer. And something else, something impossible, was happening. The temperature of Triton's atmosphere had risen by 5% since the 1980s. How? It receives less sunlight than any other world in the solar system. The sun appears as a bright star, barely brighter than a full moon on Earth. Yet Triton is warming. Scientists believe it is due to seasonal changes. As Triton orbits Neptune, its poles face the sun for decades at a time. One pole bakes in continuous light for 70 years. Then darkness. Then the other pole. The ice sublimates. Gas rises. The atmosphere grows. It traps a little heat. It creates a greenhouse effect. Small, tiny, but real. And it is happening now. Right now. As you read this, Triton is warming. Its atmosphere is expanding. Its surface is changing. And we have not been there to see it. We have not seen the new plumes. We have not seen the new patterns. We have not seen the colors shift. We have not heard the wind. We have not touched the ice. We only have photographs from 1989, and they are fading, like memories. On March 17th, 1989, Voyager 2 turned its cameras back toward Triton. It had already passed. It was leaving, and as it looked back, it saw something no one expected. Geysers, not water, not lava, liquid nitrogen, jetting upward at hundreds of meters per second, reaching heights of 8 kilometers, stretching across the sky like black smoke. Some plumes stretched 150 kilometers long. They were not eruptions. They were explosions, caused by sunlight heating frozen nitrogen beneath the surface. The gas built up, pressure rose, and then it burst. The geyser carried dust with it, dark particles. It fell back down, painting the surface in streaks of red and brown. These markings still exist today. They are fingerprints of ancient eruptions. Triton is not dead. It is active. It breathes. It bleeds. It sings in cryovolcanic songs. And these geysers are not rare. They are common. They happen everywhere. On the plains, on the ridges, on the smooth patches. Triton is not a frozen tomb. It is a living engine, powered by the sun, driven by internal heat, and fueled by ice. Triton's surface looks like nothing else in the solar system. It is covered in a strange pattern, dimples, bumps, ridges, smooth valleys. It resembles the skin of a cantaloupe melon. So scientists named it cantaloupe terrain. It covers most of the moon's equator, and it is ancient, older than anything else on Triton. It has almost no craters. That means it is young, geologically speaking. But how can something be both ancient and young? The answer lies in cryovolcanism. Deep inside Triton, heat rises. It melts ice. It creates slush. It pushes up through cracks. It flows across the surface. Then it freezes. It hardens. It cracks again, over and over, millions of years, creating those rounded depressions. Each one a collapsed dome. Each one a buried volcano. The surface is constantly renewing itself, like a glacier, but made of ice, and it moves slowly. So slowly, we would never notice. But over millions of years, it erases craters. It buries scars. It hides the past and creates a landscape no other world possesses. No Mars, no Europa, no Enceladus, only Triton. And no one knows why. Triton is the only large moon in the entire solar system that orbits backward. All other moons, including Earth's, circle their planets in the same direction the planet spins. Triton? It goes the opposite way. It is moving against the flow. This is not normal. It is impossible unless it was captured. It did not form beside Neptune. It came from somewhere else. It was once a dwarf planet, a twin to Pluto, orbiting the sun alone until Neptune's gravity caught it. It was pulled in, slowed down, captured, and forced into a new orbit. The process was violent. It likely destroyed other moons. It caused tidal heating. It warmed the interior. It melted ice. It created the ocean beneath the surface. And now, it is paying the price. Because retrograde orbits are unstable. They decay, slowly, relentlessly. Triton is shrinking, 1 centimeter per year. 3,600,000,000 years from now, it will reach the Roche limit, the point where Neptune's gravity wins. Triton will be torn apart, not by impact, not by explosion, by stretching, by pulling, by tension. Its ice will shatter, its rock will fragment, its ocean will spill into space, and it will form a ring of ice, of dust, of frozen nitrogen, of methane crystals, of broken mountains, of the remains of a world. It will be dark, it will be cold, it will be beautiful. It will encircle Neptune like Saturn's rings, but heavier, more massive, more ancient, and no human will ever see it. Because by then, Earth will be gone. The sun will have swollen. It will have burned Mercury. It will have boiled Venus. It will have scorched Earth. Life will be extinct. Civilization will be dust. And Triton will become a ring, a monument to a moon that refused to die, that fought, that lived, that sang, and then vanished into silence. Triton is small. It is far from the sun. It has no molten core. It should be frozen solid, dead, but it is not. It is warm inside. Why? Because of tidal heating. Neptune's gravity stretches Triton, pulls it, squeezes it. As it orbits, the shape of Triton changes slightly. This flexing generates heat, like rubbing your hands together, but deeper, stronger. This heat melts ice, creates a layer of liquid water between the rocky core and the icy shell. An ocean, 10 to 30 kilometers deep, salt water, possibly rich in ammonia, which lowers the freezing point. It is hidden, dark, cold, but liquid. And if there is liquid water, there is chemistry. If there is chemistry, there is potential for life. Not fish, not whales, not even bacteria, but microbes, organisms that survive without sunlight, without oxygen, living off chemical reactions, like those found near hydrothermal vents on Earth. Life in the dark, life in silence, life in ice. We do not know if it exists, but we know it could, and that is enough. Enough to make us want to go back. Enough to make us risk billions of dollars. Enough to make us say we must see it. We must know. Triton's atmosphere is not thick. It is 100,000 times thinner than Earth's. It is mostly nitrogen, with traces of methane and carbon monoxide. It is so thin, you could walk through it without feeling a breeze. But it is real, and it is changing. Since the 1980s, scientists have measured a 5% increase in atmosphere pressure. Why? Because Triton's southern hemisphere is entering summer. Sunlight warms the surface. Nitrogen ice sublimates, turns directly from solid to gas. The atmosphere grows. It traps a little heat. It creates a greenhouse effect. Small, tiny, but real. And it is happening now, right now. As you read this, Triton is warming. Its atmosphere is expanding. Its surface is changing, and we have not been there to see it. We have not seen the new plumes. We have not seen the new patterns. We have not seen the colors shift. We have not heard the wind. We have not touched the ice. We only have photographs from 1989, and they are fading, like memories. When Voyager 2 flew by Triton, it took pictures of only 40% of the surface. The rest remained hidden, because Triton rotates slowly, and Voyager passed quickly. It had one chance, one flyby, one moment. It saw the northern hemisphere in shadow. It saw the southern hemisphere lit by the sun. It saw the geysers, the cantaloupe terrain, the frozen plains, the ice mountains, but it missed the rest, the unknown, the secrets. We do not know what lies on the dark side. We do not know if there are more geysers, more volcanoes, more oceans, more life. We do not know if the ice is smoother there, or rougher, or colored differently. We do not know if the subsurface ocean is larger on the far side. We do not know if the heat is stronger. We do not know if the future ring will form from the unseen half. We only know what we saw, and what we saw was enough to change science forever. After Voyager 2, silence. 35 years, no prove, no mission, no telescope powerful enough to see details. Then, in recent years, at a conference in Houston, NASA announced a new idea. Triton, a small spacecraft designed to fly by Triton. Cost $500 million. Launch window 2026. Arrival 2038. It would carry cameras, spectrometers, magnetometers, mass spectrometers. It would fly within 500 kilometers of the surface. It would sample the atmosphere. It would measure magnetic fields. It would search for signs of an ocean. It would look for organic molecules. It would listen for sounds. It would take high-resolution images. It would map the surface. It would find out, is Triton alive? Is it changing? Is it dying? Is there life beneath the ice? It would not land. It would not orbit. It would fly, once, fast, and leave. But it would bring back data. Data we need. Data we crave. Data that could rewrite textbooks. And yet, Triton was not funded. NASA chose another mission, another target, another world. Triton was forgotten. Again, but the scientists, they did not give up. They keep writing proposals. They keep lobbying. They keep saying, this is the most interesting moon in the solar system. And they are right, because Triton is not just ice. It is a question, and we have not answered it. Triton's orbit is shrinking. 1 centimeter per year. 3,600,000,000 years from now, it will reach the Roche limit, the point where Neptune's gravity wins. Triton will be torn apart, not by impact, not by explosion, by stretching, by pulling, by tension. Its ice will shatter, its rock will fragment, its ocean will spill into space, and it will form a ring of ice, of dust, of frozen nitrogen, of methane crystals, of broken mountains, of the remains of a world. It will be dark, it will be cold, it will be beautiful. It will encircle Neptune like Saturn's rings, but heavier, more massive, more ancient, and no human will ever see it, because by then, Earth will be gone. The sun will have swollen. It will have burned Mercury. It will have boiled Venus. It will have scorched Earth. Life will be extinct. Civilization will be dust. And Triton will become a ring, a monument to a moon that refused to die, that fought, that lived, that sang, and then vanished into silence. Triton breaks every rule. It is too big. It moves the wrong way. It is too cold, but it is active. It is too far, but it has an ocean. It has no internal heat source, yet it erupts. It has no magnetic field, yet it interacts with Neptune's. It is old, yet its surface is young. It is dead, yet it breathes. It is a contradiction, a paradox, a puzzle with no solution. And that is why it matters. Because if Triton exists, then our models of planetary science are incomplete. We do not understand how moons form. We do not understand how oceans survive. We do not understand how heat travels through ice. We do not understand how life might begin in darkness. Triton is not just a moon. It is a teacher. It says, you think you know the rules. You are wrong, and we must listen, because if we ignore Triton, we will never truly understand the universe. We learned about Triton in 1989. We sent one probe. We took pictures. We listened. We left. We forgot. We moved on. We went to Mars, to Jupiter, to asteroids, to comets. We chased the bright, the flashy, the new. We ignored the quiet, the cold, the forgotten. But Triton is not forgotten. It is dying, and we may never return. We may wait until 2050, or 2080, or 2100, and when we finally send a mission, it may be too late. The geysers may have stopped. The atmosphere may have collapsed. The ocean may have frozen solid. The cantaloupe terrain may have been buried under new ice. The ring may have already begun to form. We may arrive and find nothing. Just silence. Just ice. Just a moon that died while we waited. We're not explorers. We are observers. And sometimes, observation comes too late. Triton reminds us, the universe does not wait. It moves. It changes. It dies. And we are always behind. Always late. Always watching. Never acting. Until it is too late. Triton is not a moon. It is a story of capture, of survival, of warmth in the coldest place, of life hiding in ice, of beauty in silence, of death by gravity. It is the most alien world we have ever seen, and yet it is ours. It belongs to our solar system. It orbits our sun. It is part of our family. We are not separate from it. We are connected by gravity, by physics, by time. We are the children of Triton's fate, because one day, Earth will die, not by fire, not by ice, but by silence, by time, by being forgotten. Triton shows us what that looks like, and if we do not learn from it, then we are not worthy of the stars. We are not ready for the future. We are not ready to be more than animals. We are not ready to be explorers. We are not ready to be human. But if we go back, if we send a ship, if we listen, if we dare, then maybe, just maybe, we will not just discover Triton. We will discover ourselves, and we will remember that even in the darkest, coldest places, life finds a way. And even in the silence, there is wonder. We hope this journey ignited your curiosity. Stay with us as we explore the frozen hearts of the outer solar system, the silent moons that defy all logic, and the haunting beauty of worlds on the edge of death. Subscribe and join us for the next discovery.